Hey there. Let's have a quick discussion about reference angles. It's a pretty important topic. It's going to help us do some problems later on. And it may actually be something you've noticed already about the unit circle and the coordinates. The definition of a reference angle is the acute angle that the terminal side of an angle makes with the x-axis. The acute angle that's less than 90 degrees that the angle that we're talking about makes, the terminal side, makes with the x-axis. I like to think of that as the shortest distance from the terminal side to the x-axis. So let's take a look at some reference angles here. This is pi over 6, right? Okay, here's 5 pi over 6. 7 pi over 6. And 11 pi over 6. Okay? Alright, so let's take a look at these four angles. We said that the reference angle is the shortest distance between the terminal side and the x-axis, or the acute angle the terminal side makes with the x-axis. So in all of these cases, we're talking about this much of an angle. That angle right here, we're not really talking about positive or negative at this point. It really doesn't matter. We're just talking about the measure of that angle. I hope you can see that in every single one of those cases, the reference angle is identical. That angle is pi over 6 in each case. It's 30 degrees if you want to put it in degrees. There's 30 degrees of angle in each one of those reference angles. Why is this important? Well, I'll tell you why it's important. Because if we look at these four coordinates, let's write them. You should know what they are. Radical 3 over 2, 1/2. Negative radical 3 over 2, 1/2. Negative radical 3 over 2, negative 1/2. And radical 3 over 2, negative 1/2. Do you notice something? I should hope so. That all of these angles that have the same reference angle, pi over 6, have the exact same coordinates other than sign differences. And the sign differences you can get from the quadrant, right? Quadrant 1, x is positive, y is positive. Quadrant 2, x is negative, y is positive. Quadrant 3, x and y are both negative. And quadrant 4, x is positive and y is negative. Okay? So what we're saying is that if two angles have the same reference angle, they're going to have the same coordinates. And therefore, they're going to have the same trig functions other than sign differences. Okay? Pi over 6 has a cosine of radical 3 over 2. 5 pi over 6 that has the same reference angle of pi over 6 has a cosine of negative radical 3 over 2. Same magnitude, just different signs. The sine of each is a half. The sine of all four of these is a half with sign changes, and so on. And that can be said, that can be true of any pair of angles that have the same reference angle. How about this one? That's pi over 3, right? Well, what about down here? 4 pi over 3? That has the same angle, same amount of angle. So everyone see that this blue line right here, this angle is the same amount of measure as this angle here. They both have a pi over 3 reference angle, 60 degrees, which means that their coordinates should be identical except for signs. Okay? And you should know what the coordinates are. For pi over 3, it's 1/2 radical 3 over 2. And for 4 pi over 3, it's negative 1/2 negative radical 3 over 2. And this is going to hold true for any angle that has the same reference angle. So this one here and this one here. And you should see another group of another group of angles that have the same reference angle here, 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 and here that all had the same reference angle of pi over 4. So that's reference angles. Again, any two angles that have the same reference angle, the same shortest distance to the x-axis, will have the same coordinates and therefore the same trig functions except for sign differences. That's reference angles. Thanks.